It is a way in JavaScript you can use to measure how long any piece of code can take during execution. So let's see how you can measure the performance. So here I have two functions which exactly return the same result or do the same thing. The first function is this one. It is using a loop. It is accepting a number n, and it has a variable total at the top, and then it is iterating from 1 up to n included, and then all it does is to calculate the sum of all numbers from 1 up to n included. Then after that, the function is returning the total and the total sum. So the second one also is the similar function but with a different implementation. So here we are taking a number n times n plus 1 over 2. So let's display the result, both of the result and see node. So the first one is giving 50-50, and then let's log the second one also. As you can see also, it is providing 50-50. So both functions are providing the same result with different implementations. So let's see how we can measure the performance to see which one is faster between the two. So how to do this? I will declare a variable t, which is stands for time 1, or like the first time before calling our function. So I will use object performance, and then on this object I'm calling the function now, and then after calling my function I'm going to grab the time 2, and then I will use again object performance. On this object I will get the function, this function now, and then here in this log function I'm going to calculate the elapsed time, which is going to be t2 minus t1 t2 minus t1, and this is going to be in a millisecond. So I will convert it into second by dividing the entire calculation by 1000. So this is going to be in seconds. So let's copy this implementation to the second function. So then we are going to learn to see which function performs better in a few seconds. So let's begin by the first function. So as you can see, we are getting this amount of seconds. Let's run the second one. So see, as you can see again, so we are getting this number of seconds. So as you can see, there is some differences, because you can see here we have 6-1, here we have 4-3, which means the second one is faster than the first one. So let's supply a huge number so we can see the difference very quickly. So let me add let me say we are going to supply 1 million. 1 million, 7 million, 1 2 3 So let me run it again. Again, you are going to begin by the first one, and then let's run the second one. So as you can see, on the first function we are getting this amount of seconds, 0.01508. Then on second one we are getting 0.00064,199. So as you can see, it is clear that the second function is way faster than the first one. So let me add the other 3 zeros. We are going to test this implementation by supplying 1 billion. And then let's clear the terminal. We are going to start by the first one again. You can see it is taking a few seconds to run. Now you can see we have 1 second 0.6. So let's run the second one. So you can see even the time, the run time is way quicker than the first one. So on the first one you notice that it is taking time to show the result, but on the second one it was like somehow quick. So as you can see now, it is clear we have 1 second here, but here we have 0.00 zeros, then 31599 seconds. So this is how we can measure the performance of any piece of code in JavaScript. Now let's measure the performance of our function through the lens of big O notation. So by using big O notation, all we have to do is to determine how many simple operations which our system has to perform on both of the functions. So let's begin by function 1 right here. So as you can see, we have this operation. This operation is going to be only once at the beginning of the loop. So we are initializing our total by 0, and then here we have again this assignment operator. Also this is happening only once. So but here we have I less or equal to n. So this will increase according to n. So if n increases, so we are going to have also n comparisons. So n comparison operators. And then next here we have I plus plus, which is a shorthand for I plus equal to 1. So which means as n increases, also we have plus or addition operations and assignment, n plus operations and n assignment operations. So as n increases, also we have more additions and more assignments. Similar goes to this one inside the loop body. We have total, which is getting the summation of both of all numbers from 1 up to n included. So we are saying total plus equal to I, which means we have n operations or n operators which our computer has to perform, and then n assignments which our computer has to perform. So the body of this loop runs n times. So which means this will run only once. The first one will run will only happen only once, and again this will be only once, but this one will be n times, same to this one n times, and same to this one n times. So when you are supplying a small number like 10, so this is not going to be a problem. But so when is it going to be a problem is like when you have a huge number like this 1 billion. So this is going to be a billions time this one also. It is going to be 1 billion time. Even this one is going to be 1 billion time. So through the lens of big O notation, so our function, you can say it is our function is O of n. You can say our function is O of n. So why n? Because we have n operations. So we will take the big one. So we say that if n is somehow big, so you are going to have n operations here, again on n operations here, same here, n operations. So this one we said it will only be once, same here. So you are going to ignore this one and this, so and then you are going to consider these ones, this one which is going to happen n times, same here, and then same here. So which means as n increase, also the number of operations to perform will increase. Then moving to the second function, so let's say we have multiplication, addition, and division, which means we have only three operations our system can perform. So meaning that the operations here compared to the first one, so the first one operations or operators will increase according to the size of n. But here, so no matter how n is, so we'll still have 3 operations, which means here the operation to be computed by a computer still remains constant. So here through the length of big O notation, then our function will be O of 1.